So it's nice to see so many new faces. And those of you that are new, we've hit a home run because we have Phil Calabrese today. Phil is he's a tremendous force in the Urantia movement and in the scientific community and mathematical community. Dr. Phil, and I told him this would not be the Dr. Phil show, Dr. Phil Calabrese is a research mathematician and inventor of an algebra of conditional propositions that has been widely applied to combine and deduce uncertain conditional information in a way faithful to both logic and probability theory. I'm not sure what that quite what that means, but maybe you can help us understand that. During an initial 14-year teaching career from 1968 to 1982, Phil taught college-level introductory statistics and probability courses over 45 times. Phil started presenting the cosmology of the Urantia Book at Urantia gatherings in 1971, and he continues to do so here today for us, applying his knowledge of statistics to test the Urantia Book's claim of superhuman authorship. Phil Calabrese.
Good evening, everyone. I hope you haven't eaten so much that you don't have any brain cells working anymore. But as most of you know, the Urantia Book was first published in Chicago, I think I'm going to take this out, in 1955, claiming to be an epical revelation of divine truth to our world called Urantia. It has been 58 years since then, and now it's possible to evaluate how likely that is, how likely that claim really is. I wrote this paper for scientists and skeptics, not for folks who already recognize that spiritual, intellectual, and material scientific truths that are contained in it. So this paper represents a rigorous statistical test and a framework for periodically rerunning the test as more human science is learned. So to run a statistical test, one must have already a prior knowledge of the distribution associated with the null hypothesis. That's the hypothesis that the Urantia Book was authored by human beings. So you need to have some kind of a priori distribution to test against. For instance, knowing that wood can hardly grow unaided into the shape of a four-legged chair in a wooded forest, if we encounter such a piece of wood in the forest, then we are justified in concluding, statistically, not logically, that it was designed and built by some intelligent agent rather than that it evolved or emerged into a chair by wholly non-intelligent means. In this case, we have an a priori probability distribution of wood growing in a forest. We've all been in forests. Has anybody ever seen a chair grown out of the wood? I don't think so. I mean, this one is obviously done by someone, some intelligent. And so you conclude statistically that this was done by some intelligent person, not just emerged or grew out of the wood. Well, similarly, suppose I have a coin and I roll it 100 times. If you see the blue area there, if it's a fair coin, that's how many, you're likely to get of each type. For instance, what's the probability of getting exactly 50 heads if you flip a coin 100 times? Well, you can see it right over there to the side. If you just move from here over to the side, you can see, well, roughly it's less than 10%. It's maybe, 8%. So 8% of the time, you're going to get exactly 50. Then you get 49 or 51 or 48, 52, and it falls off here. And I don't know why I'm getting a message, but I'm going to turn off my phone now, or at least quiet it. So if we were to flip this coin and maybe 30 heads came up, whoops, if 30 heads came up, well, the probability of that is down to practically zero. So if the probability is practically zero of 30 or less heads coming up, you might statistically conclude that the coin is not fair. Now, that doesn't mean it's impossible for it to be fair, but it's very unlikely that a fair coin would give you 30 heads. Well, that's the way statistical tests are done. You have an a priori distribution, you know what's the likelihood of a head and a tail, and then you run a test, and if it turns out that what you get is so unlikely, and there's usually a cutoff point, then you conclude that, well, the coin is not fair. And the other colors are with different numbers of flips here. You can have 20 flips or 6 flips, and these are the distributions. So here is another, this is where the probability of heads would be different probabilities here, different percentages. Maybe you're not flipping a coin, maybe you're rolling a die. And then you'd have, let's say, 1 chance in 6 of getting something, and 5, 6 getting something else. And so you get a different kind of a shape, a distribution here, but they all have pretty much the same shape. So now, human life on Earth. Here's some human life on Earth. And here's some humanoid life hypothesized on some other world. What's the probability of life on another world, on other worlds? Some people keep talking about that. It's, come to think of it, it was just today or yesterday that I came up with, I guess, a newspaper article about how we've just decided that there are 200 billion estimated number of stars and so many planets like ours in those stars. So maybe we have an estimate now of how many planets might be out there like ours. But that doesn't tell us what the likelihood of life on those places is. What's the probability of life popping up out of chemistry and physics? We have various theories, complex organisms emerging from simpler ones. But the problem is always, where did the new generation come from? In other words, we have pretty much the evolution of life, maybe even from single-celled organisms. But we don't have any evidence of life popping up out of physics and chemistry by itself. None. Absolutely none. Have they ever been able to take a dead body and, bring it back to life by doing, well, adding whatever it's lost. So life has this capacity to adapt to stimuli. it reacts differently to repeated stimuli. Well, physics doesn't do that. Chemistry doesn't do that. They're uniform. So how do we get the non-uniformity of life, the ability to adapt, out of uniform physics, uniform chemistry? So without much knowledge of how complex organisms emerged, quote unquote, from simpler ones, there is no clear way to test the hypothesis that the human eye, for instance, required intelligent design because it was supposedly irreducibly complex, that it would have to be some kind of an intelligent being who would have designed the eye. I think that's a very difficult argument to make, and we want to make simple arguments. So, you know, the origin of life has a lot of controversy about it, whether or not the cells came first or whether or not somehow or other. I'm not going to get into that, but I think it's an example of, well, there's a lot of examples of old science that we change our minds about. This is pretty old, you know, because at one point we used to think that the stars were stuck up there in a dome, and you could stick your head out maybe on the side and see what's on the other side. Famous painting. Here are some more errors of science once thought and who corrected them. And, you know, this is anywhere from the 1600s to the 1900s. And these are all things that scientists once believed. You know, the circulatory system was mistaken, and the earth was thought to be the center of the universe, and germs are no problem in surgery at one point, until Louis Pasteur decided it was. DNA was not so important for a while. The atom was considered the smallest particle for a while. So you can go down, and heavier objects fell faster than lighter objects until Galileo actually tested it. Before that, everybody assumed that they did. So there's been a lot of errors in science, and here's some science that's occurred since 1955, which is when the Urantia Book was first published in Chicago, printed by R. Donnelly and Sons. So these are things that were discovered after the Urantia Book was published. The discovery of the neutrino, well, you know, there was some hint of this in the earlier days, but it was a minority position, and that's an important thing to keep in mind. If it's a minority position, then most of the humans were taking the majority position. And if you find that, you know, the Urantia Book takes the minority position when it's right over and over and over again, and doesn't seem to fall for various things that we've subsequently discovered are incorrect, such as the Piltdown man hoax, then we begin to think, well, how in the world could humans have done that? We know what the probability of a human taking a position at the time in 1955 or earlier by just counting up who was publishing what. At least in theory that's the case, but I didn't want to have such a hard time with all the data, so I figured out how to do it without that. That was what took me most of the time. In 1955, remember, we didn't have computers. At least not very, well, we had one. Here was one, it's called the Brainy Nork. It was considered really very fast, 15,000 arithmetic operations per second, and 1 billion in less than 24 hours, and this is equivalent to 1,000 persons calculating on paper for a lifetime, it says. Well, Now, we have computers that are 10 million times faster than that. So, but there were no computers to speak of at the time. So here are some astronomical predictions actually made, and that's a direct quote. And this is in a 1955 book. In the not-distant future, new telescopes will reveal to the wondering gaze of Urantian astronomers no less than 375 million new galaxies in the remote stretches of outer space. Well, when that was stated, we were sure of maybe 200. Certainly not millions. It went up to maybe 5 million by 1990 something, and then they looked out there and they found the first deep space. Here's another statement here. First deep field, the Hubble Deep Field, was observed over 10 consecutive days in 1995, and almost 3,000 galaxies were seen. And these are all galaxies in there. Some of the ones are close. You can see them, but in the faraway distance, you have all those specks. They're not stars. They're galaxies. They're star systems. And so all of a sudden, from 1995, we start seeing what the Urantia Book said 40 years earlier, or it published 40 years earlier. So here's some more. And it also predicted the voids between that we now observe. You know, they have these huge areas where there is no appreciable star systems. And again, there are various quiet zones, relative quiet zones between these levels that are described. And you can see here the great walls, they're called. The great walls of galaxies are separated by zones of relative quiescence. It also predicted dark matter a long time before it became popular. And it, in fact, says that if it wasn't for these huge dark masses, various star systems and stars would just be pulled into nearby systems. But because of all this gravity attraction around it, they're just sort of held in place. That is something we have subsequently discovered. It was, in fact, Vera Rubin who confirmed this. It had been stated by a physicist, Zwicky, I think his name is. Yeah, but he was in the minority. People didn't believe him. Most people were saying something else. Well, Vera Rubin was looking out at the Magellanic Cloud and found out that these things were spinning so fast that there had to be 90% more dark matter to keep the thing from flying apart. So that using the redshift, they could tell how fast things were spinning, because on one side of the galaxy it's coming towards you, and on the other side it's going away. So with the redshift, the difference, they could tell how fast that thing is spinning, and they say, well, if it was just luminous material, it would fly apart. There's got to be a lot more there that's holding it together. So yeah, Zwicky. Had analyzed these Doppler velocities for whole galaxies, and he found that the individual galaxies within the cluster are moving so fast they would escape if the cluster were held together only by the gravity of the visible mass. Now, this was 1933. But you notice his colleagues had been skeptical. It was Rubin who in 1970s finally confirmed this, and now everybody agrees. Well, if the Urantia Book had followed, everybody else instead of this one person, you'd say, well, so what? I mean, that pretty much discredits it. If they're saying that something different than what we have discovered. Now, we keep changing our minds too, so it's a little hard to be for the Urantia Book to be right all the time if we change our mind. So, the null hypothesis is then that the Urantia Book was authored by humans, and the alternate would be that the Urantia Book was not authored by humans. You can decide, afterward whether who authored it if it wasn't humans. So I spent a lot of time, years actually, thinking about how in the world to do this so that it wasn't too complicated. So I finally settled on the idea that the test population should consist of all well-established present-day, this is when I wrote it, August, scientific statements for which the following are true. The statement consists of some well-established information that only a minority of a third or less scientists espoused prior to 1955. Call these reversal statements. Statements that science has changed their mind on or has found some new information about. Secondly, the Urantia Book, somehow it does express some definite opinion about this post-1955 scientifically well-established information. If the Urantia Book doesn't say anything about it, then it can't be used as a test. And then finally, the reversal statements have to be probabilistically independent. In other words, you can't flip a coin, and flipping coins are independent. So you want these examples to be independent. So those three things, which statements then, well, let me first of all qualify the test procedure. They have to be independent, and there's some judgment sometimes in how many independent statements one should use to cover some topic. For instance, in covering new information about the outer space galaxies, beside the numbers of galaxies, there are the related facts of large-scale structures among them, the huge voids, and the high percentage of dark matter holding the spinning galaxies together, all predicted by the Urantia Book. But the question is, how many independent statements should cover the outer space galaxies? Because, if they're not independent, then the test wouldn't be valid. So, in theory, every scientific reversal statement, each one there's a historical record of the percentage of scientific authors who espoused or published, namely that in that day, what now is considered contemporary scientific understanding. So if you turn that into a percentage or a fraction, that can be the probability that a human being at the time would say the right thing, would know the right information, would express what Zwicky said and not what everybody else was saying. And 1 minus that fraction would be the probability of human doubt or making a mistake. So there is an a priori distribution. That's the point. The fact is that we know who published what they were saying at those times. So we can test against that a priori distribution. So here's the simplification. It won't bias the population toward or away from accepting the null hypothesis, but it will greatly simplify the historical data collection to restrict the population to all and only those scientific reversal statements for which, according to present-day scientific knowledge, 2/3 or more of the scientific opinions in 1955 were wrong or expressed ignorance. So I'm going to say, let's not take any 50-50 questions. If most 1/3 or less of the human beings were expressing the right opinion, then we'll take that one. If it was a 50-50 kind of a thing, then let's just not bother with those. But that doesn't bias it one way or the other. Secondly, for any statement whose fractions of incorrect human scientific opinion in 1955 was even greater than 2/3, it will suffice to assign the same 2/3 value, as though 1/3 of human scientists at the time expressed the correct opinion. So this gives to the null hypothesis any benefit in likelihood due to the simplification. So that's important to realize. In other words, suppose that only 1 in 10 human beings were expressing the right information in 1955 or earlier. Well, I'm going to say it was 1/3. That gives to the null hypothesis any increase in likelihood due to that simplification. It makes it more likely that we'll accept the hypothesis, not less likely. But it greatly simplifies the test, and it turns out we don't need we can still do the test with that simplification. So the test can be done using what is called a binomial distribution, which is basically coin flipping or similar or dice throw, with the probability of failure equal to 2/3 for each of the reversal statements. And we could test this as rolling, or think of this as rolling an ordinary 6-sided die, having numbers 1 through 6 on its faces. And the number of rolls will be the number of independent reversal statements. And for any reversal statement, human error will be represented by the die faces 1, 2, and 3, 4, giving it 4 out of 6 chances, or 2/3. I hope I'm not losing you. The faces with 5 or 6 will represent correct human statements. Thus, in this n rolls of a die model, the probability of a human error or failure is going to be 2/3, and 1/3 is the probability of a correct human statement. It'll actually be most of the time even less, but it'll be okay to do it that way. So, if I had 48 ordinary die, just happen to have 48 human die. Now somebody took my prop. Oh, here it is. That's laid plant, And so if I were to put this down and roll, this is actually 48. I counted them earlier. 48 dies, if I can just get this thing open.
How about I hold the mic for you while you open it?
I got it now.
Okay.
And if I just roll these dies, the question is how many 5s and 6s will I get? Because there's only 2 out of 6 chance. And if I got 48 independent, I didn't want to do it 48 times, so I just roll 48 dice. Figure that's close enough to independent. And then we count the numbers of 5s and 6s. Now, if it's 48 dice, you expect about 1/3 of 48, which would be 16, right? 16, 32, 48. You expect about 16, give or take. Yeah. Now, here's the distribution. It's focused on 32. That's the number of errors that you expect. And you can see, the errors might be more, it might be less than 32, but by the time you get to about 21 or 20, the probability of getting any fewer than 20 errors is getting very small. In fact, you know, getting less 21 failures is actually 0.000329, which is less than 1 chance in 3,000.
What did you count?
14. So 14, it would be, if we subtract that from 48, would be what? 36, no, 34. 34, and you can see 34 is not a very unlikely thing here, right? 34 is right there. So, you know, that's right in there what you'd expect. You'd expect to get something in there. You expect all of the numbers to be in that area, and very infrequently are they going to be on the outsides of those things. Okay, let's run the test. And I have the examples, but I'm going to give you an opportunity to ask about them. There are 48 independent examples that I've listed, and the probability of failure is 2/3. And when I check these out, I get only 9 failures. And that means I've got 39 successes. So it's like having 39 5s and 6s in here. But that's an awful lot. So the probability of having 9 or less failures in 48 tries, a failure would be 1, 2, 3, or 4. So imagine getting 9 or less 1, 2, 3s, or 4s. You counted 14. Everything else is a 1, 2, 3, or 4. So the chance of that is less than 1 in 50 million. So therefore, I'm going to reject the hypothesis. It's just so unlikely that the Urantia book could have been right so many times and not wrong so many very often. So that's how we. Now here are the examples that I have put up in physics. Since we have a physicist here, I'm going to stop here a second and let you read that. And I have references on every one of these. And I've got Wi-Fi. Well, actually, I don't need Wi-Fi. I've got a cable that will allow me to follow a link. So I would ask anyone here a random person pick any one of these examples, and we'll follow it up. And after we follow up 2 or 3, and you'll say, well, he's got references for the 2 or 3 we picked. What's the likelihood of that unless he's got them for all of them? And I do. I have them for all of them. So these are some of the things. I mean, neutrinos coming from supernovas, and they have mass. That wasn't known before until after the Urantia book was published. And amazingly not, there are some equations in there that done by analogy that'll give you the size of the electron and the proton. Using a proportion, they'll do that. Okay, I want to go through. This is the physics. There's astronomy. Cosmic rays, very high energy from far outer space, escape from black holes, cascade in the upper atmosphere. That's now understood and known, but it wasn't back then. We have learned that space not only expands, but it accelerates. The expansion is accelerating. The Urantia book describes expansion and the fact that there's a periodicity to it. Well, if there's a periodicity to it, there's going to be an acceleration phase. And it says we are in midway into the expansion phase, and so therefore there would be an acceleration right about now. It accelerates right into the inflection point, and then after it gets through that point, and it starts slowing down, and then slows down and then comes back. At least that's what the Urantia book describes. It happens to fit the data, because now we're wondering how in the world we're thinking about dark energy to explain why space is expanding and accelerating, I should say. So we keep coming up with, I say we, our scientists, come up with new information and new explanations, and we find so much of it in the Urantia book. There's more in the astronomy area. So I took the C's referred to converging to what the Urantia book says. The D's refer to divergent, or still not agreeing. For instance, the birth of the solar system is now still considered a condensation type of evolution, that somehow or other the gas just kept coming closer, gravity, and made it get hotter, and by collapsing it, and until finally a nuclear explosion, chain reactions would occur. That's our present description. But, I think I'm waiting for them to change their minds about that. So, biology. Right now, the Urantia book says that life started around 550 million years ago. It was implanted here. Well, we got a D there. We obviously don't, this contemporary science has it going way back earlier now, much earlier. So, I put a question mark on the number 28. There are a couple of, there are actually 50 examples, but I have 2 question marks because we're not sure, and it's not a well-established yet how the dinosaurs ended. So I didn't include that one in the actual statistics. Paleontologies. The Piltdown Man is a good example of how the Urantia book doesn't make blunders. It talks about Java man. It mentions Neanderthal man. It mentions Peking man. It mentions 2 or 3 other kinds. But they specifically don't mention Piltdown man, which was the double fossil hoax done in 1920s, perpetrated. Over 500 scholarly scientific articles written about the Piltdown man. Before 1950s, Ashley Montague challenged the fossil, both of them, and they were found to be hoaxes, a fraud perpetrated on science. Well, the Urantia book doesn't swallow it. It says, but you'll never find, this was the missing link fossil, by the way. And the Urantia book explicitly says you'll never find a missing link for the simple reason that none ever existed. The fossil was a tooth of a man and a head in a jaw of an ape, something like that, but it had actually been glued in there. Geology. When the Urantia book was published, we didn't exactly know how old the Earth was. It was anywhere from 2 to 10 billion years. The Urantia book gets it right on the button. 4.5 billion years. And that's in there. It says 4.5 billion. It doesn't. We're not talking about vague statements. So I have those examples. See if I can get this on here now. I have those examples on my well, let's try this again. And then let's try this. There we go. So this is the paper that appears in the Fellowship Herald by the same name, Statistical Test, and at the back I have listed. Well, I have these. I'm looking for the examples that I have at the end. I guess here they are, all numbered. So each of these has their own reference, each of those 48 examples. And so, for instance, if you were to say, well, all right, why don't you choose one? Take a number from 1 to 48 that we can follow up, or any of the ones that were of interest, and we can follow that up. Or we can just put it out to questions if you want to be specific. Maybe I'll go to one of those to elaborate on it. But for instance, here's a link to a paper having to do with Tycho Brahe's nova. And the Urantia Book gives information we didn't know at the time, and subsequently we've found. Let's see here. I guess I need to. I'm not sure I can bring that over there. Well, let me ask, put it up for questions because I'm having a little technical trouble here getting that up. Any questions? Yeah. Okay. All right. Let's see if that was number 40. Yep, here it is. Okay, now here's the Urantia Book statement. If I can get this up. Oh, yeah, here's what I want. Well, this is where it is in the Urantia Book, and here's the quote. Neanderthal absorption had greatly retarded the culture of the blue man, and for some reason, this is not giving me what I wanted. Yeah, I guess. I'm not sure why that's doing that. I wanted to go to number 40. Let's try this link here, if I can get this up. Not getting it. Doesn't move for some reason. Who said that the Wi-Fi? We had internet. I guess we have it, but I'm not getting the thing to come up. Well, I'm not sure why that's happening. I'm not getting the it to come up like I'd expect it to. Maybe if I just copy this and paste it into Firefox, it'll come up maybe that way. It says it's transferring. Let's see if it does it. Pretty slow. Okay, here it is. Did your ancestor? I guess that's what we wanted. Did your ancestor date a Neanderthal? Why am I having trouble getting this thing over the side though? Yeah, probably it was this thing. I don't know. Maybe if I get rid of that, I wonder if I can now see. Okay, yeah, that did it. Okay, so it says, so did we or didn't we? Last week saw the publication, I guess it's not up there now. I'll read it. Of two new papers with diametrically opposed conclusions about whether non-African peoples have Neanderthal human hybrids among their ancestors, a result of at least some interspecies dalliance in the distant past. I'm surprised this is not on there. For some reason, it's not doing it. If I do this, it went on there before. Let's see if it does it now. Yeah, but it puts me off to the side and I can't read it very well. Anyway, we've learned that we did, in fact, have some dalliances with the Neanderthals. So that's corroborated in the Urantia Book. It's stated in the Urantia Book. We are now saying scientifically that we have evidence of that. Questions? Yeah, Michael. Well, as I said, I only get nine errors, 9 1s, 2s, 3s, or 4s, and everything 5s and 6s, out of 48 chances. Imagine the likelihood of throwing 39 5s and 6s. That's the result of the test. Now, this test can be done, next year or the year after. As we get more information, I expect those D's and C's to flip back and forth a little bit. Maybe we'll decide that the solar system really was not a condensation type. Maybe it was something else, like is described in the Urantia Book. Maybe we'll decide other things, like the Big Bang. The Urantia Book does not support the Big Bang, even though it talks about the expansion, talks about the red shift, but it says we're misinterpreting the red shift. It says that these things are not really expanding at the rate that we think, that there are numerous factors of error that contribute to this. So the Big Bang is something that the contemporary science believes in, claims that it's almost well established, basically well established on the basis of just the background radiation, which I think there's other explanations for. I don't think the Big Bang is so solid, but at least now people claim that it's well established. So I put that in as something that was a D, not a C. It's divergent from what the Urantia Book is saying. Yeah, Pat.
Bill, besides the only factors that you could use to set up this hypothesis are in the scientific world, right? There's not much we can do with our historical knowledge because of the fact we don't have really good knowledge of prehistory compared to what we might in terms of the scientists can come up. Maybe I'm not phrasing it.
I'm not sure, yeah, what you're
You use
getting at.
astronomy, biology, anthropology, and several other factors to test your hypothesis against in relationship to what you're interested in.
Yeah.
There's really nothing else in the Urantia book that we can use in a similar way besides just those factors.
Oh, no, I'm sure there are more. I have managed to, I tried to, cover everything. And I think if new information keeps coming up, some things are coming up and then they'll be added to it. The test should be run, periodically. So I'm not sure what the thrust of your question is. Yeah, these are not the only 48. Other things could be added.
So like for instance, we've just recently discovered the ruins at a place called Gobekli Tepe.
Mm-hmm.
And prior to and that's like they dated at 12,000, 15,000 BC.
Yeah.
Going down here.
Yeah.
Prior to that time, we really didn't have any idea at all that there would be beings around who had that kind of sophistication to build those kinds of structures.
Yeah.
That would be dated that old.
Yeah.
And so that would be, to me, another example.
Sure.
Of saying,
Yeah.
well, the Urantia talks about beings, then talk about the Andites or
You mean human beings? Yeah.
human beings who had a highly superior awareness.
Yeah. Yeah.
But a very isolated part of the gene pool, not a globally widespread, at least at that time. So those are the other things that you can look at.
Yeah, and I mean, the thing about it is you have to take something that's fairly cut and dry. You don't want any, fuzziness. Either there are over 375 million galaxies out there or not. Well, now they're saying there's over 1 billion. Well, that's over 375 million, but you know what? They're extrapolating that. Our scientists think of the whole universe as basically the same in all directions. But the Urantia book says it's basically flat, spinning and flat. So we've got presumably less galaxies above and below the plane and a lot along the plane. And we can't even see the plane because of all the dust and everything else. That's why we see the Milky Way. Whenever you see the Milky Way, there's just big dark thing in the middle because of all the dust. So we can't see really on the plane of creation. And so what our scientists are doing, we're still assuming that it's the same in all directions. But that's not a well-established fact. They don't have they don't have data. They basically have a very, very small areas that they've looked far away in, and they say, oh my gosh, look at all those galaxies. If that continues everywhere else, there'll be billions. So, but there certainly are a lot of them out there, and the Urantia book predicted it in 1955. That wasn't demonstrated until 1990s. So one mistake like that, one thing that turns out to be really wrong, like if they had talked about the Piltdown Man, it would have discredited the Urantia book, in my opinion. One mistake like that would have discredited it, but I can't find that kind of mistake. I can find some things that disagree with our contemporary science, but you know, I think contemporary science may come back. Right now, an example is the distance to Andromeda. It used to be, we thought it was less than 1 million light years. Now our estimate is over 2 million light years. And the Urantia book says that the light took almost a million years to get here from Andromeda. So that seems to be divergent. But every once in a while, we come up with a factor of 2 error of this or that. I mean, they just made the size of Andromeda 3 times as big as they thought it was. So we're still learning, and as we learn more, the Urantia book seems to, you know, fall in the right direction all the time, almost all the time. So on that basis, I'd say human beings couldn't have produced this in 1955. So the alternative is superhumans produced it. Or someone had more than human knowledge to produce it. And the Urantia book says that it's a gift to our world from the angels and higher. We certainly could use the help. So I guess I'll end on that.